Hello students.
In the previous session, we have discussed about friction, causes of friction and types of friction. Let us discuss about the different types of friction in detail. Now, we will do a small activity to understand the nature of friction, especially the concept of static friction. The materials required for the activity are toy trolley, small wooden block, one inextensible string, weight hanger, weights, pulley and table. First, place the toy trolley on the table, tie the inextensible string to it and pass the string over a pulley. Number 2. Fix a weight hanger on the other end of the string. Number 3. Keep a small wooden block on the toy trolley and put a small weight on the weight hanger. What do you observe? The trolley with the block on it moves towards to left with an acceleration. Here, the block is at rest with respect to the surface of the trolley, but it is in motion with respect to the surface of the table. Now keep on increasing the weight on the hanger. What do you observe? The toy trolley continues to move towards left, but wooden block falls onto the right side. What is the reason for this? The surface of the trolley tries to keep the block at rest with respect to its surface. If we increase the acceleration of the trolley by increasing the weight, then at a certain limiting weight, the block comes into motion. That means when trolley is applying force on the block, at the same time, block also applies same force in the reverse direction. As a result, it falls down. So, in the above activity, the block is at rest relative to the surface of the trolley up to certain limiting weight or limiting force. This is static friction. Static friction is defined as the friction which comes into play when surfaces of the objects are at rest relative to each other, even though some external force acts on them. Let us see another example. Try to move a heavy sofa. What happens? Even though you apply certain force, sofa doesn't move as the force applied is balanced by the static frictional force. As you increase the applied force, static friction also increases because static friction is a self-adjusting force. When you increase the force applied, the sofa begins to move. Let us discuss the scenario with a graph. In this graph, applied force is taken on x-axis and frictional force is taken on y-axis. As you increase the horizontal force applied, simultaneously, the frictional force also increases to keep the object at rest. Until the body is at rest, static friction will act. When sofa begins to move, sliding friction comes into play. The point at which the sofa just begins to move is called breakaway point. The friction which comes into play when the surface of one object moves relative to the surface of another object is called sliding friction or kinetic friction. To move the sofa from rest, it requires more effort. But when sofa is in motion, it needs less efforts to keep the sofa in motion. Therefore, sliding friction is less than static friction. Why the sliding friction is less than static friction? When the irregularities present in the surfaces of two objects in contact get interlocked with each other, friction comes into play. The time given in sliding for interlocking is very small. Thus, interlocking is not strong. Therefore, less force is required to overcome the interlocking. Due to this, sliding friction is less than static friction. In the same manner, it is easier to move a box which is already moving than the box which is at rest. This is because when a box starts sliding, the contact points on its surfaces do not get enough time to lock into the contact points on the floor. Thus, sliding friction is less than static friction. Can you give some more examples for sliding friction in your daily life? Sliding on a slide, skating, polishing a surface with sandpaper, etc. Let us discuss another type of friction. Pull a suitcase and a trolley bag. Which one moves easily? Yes, your answer is correct. It is trolley bag. Now take a book and few pencils. Place the book on the table and push it. Is it moving very smoothly? Now place the pencils on the table and keep the book over them. Push the book. What do you observe? When the book is moving on the pencils, it moves easily. Here, the pencils act as rollers. Do the rollers increase or decrease the friction? Yes, rollers reduce the friction. From these activities, we can define rolling friction as when one body rolls over the surface of another body, the friction offered is called rolling friction. Sometimes we hear some noise from fans. Let us understand the reason for the noise by this activity. Take two lids and rotate them by putting one on the top of the other. What do you observe? The lids rotate hardly. Now keep few marbles between the two lids and rotate. What do you observe? It is easy to rotate the lids with marbles kept between them. This is the principle of ball bearings. A bearing in which the parts are separated by a ring of small freely rotating metal balls which reduces friction is called a ball bearing. Ball bearings are used in wheels, fans, DVD players, skateboards, blenders, etc. Let us discuss one practical application of rolling friction. Imagine a worker has to push a heavy trunk. What should be done to reduce his effort in pushing it and why? The workers should put some cylindrical logs of wood under the trunk. In this way, the area of contact between the two surfaces is reduced. Rolling friction is less than sliding friction. Answer the following questions in your classwork. Question number 1. Arrange static, sliding and rolling frictions in decreasing order and justify your answer. Question 2. Can we reduce the friction to 0? Question 3. Why luggage bags are fitted with rollers? Thank you.